ladies and gents, consider the problem to determine the indefinite integral of x times the cosine of x. That problem requires the integration of a product of one function x and another function cos x, and then multiply. Remember that we had a product rule in differentiation for functions that multiply each other. A little bit similar to that. There's a formula, but there's also a method that needs to be used. Okay. So in order to integrate this type of function, we need to use the formula. By the way, in the formula, okay, what it says is the u times dv is equal to u times v minus the egg by du of both functions of x. So in this example, we'd set one of the two functions for u and the other function for dv, and then use the. Okay. So to use this form also requires a procedure to be followed, a bit like and that's by us through, and so if we take times cos x dx, first of all, you need to assign the two functions to the variable. There's a need to do this carefully, apparent in later examples. It's not always necessarily arbitrary which do dv. This needs to be so that integral on the right hand side, after inserting into the formula, it's one that we can integrate to the integrals. So it needs to be simpler than what you've already got effectively. Will become a right. So if we take this arbitrary equal to x, one side of the put in 2 like we've done before. If we equal cos x. The difference of function x du 2 and then that is 2 du equal to d. And the other, what we need to do is integrate to find if we this is the differential of effectively, so we end up with v. Say v is equal is okay. But we can add that at the end of the process after we've inserted everything into the formula to integrate by part. Okay, so although technically there'd be a T on there, at this moment in time we can leave the end. What we need to do now is put all of this in the formula integration by. So what we want is, I'm going to spread this out, dv is equal to u v minus the integral of v and then that bits that we've calculated and rearranged. So we want u v cos x equals x. Sin x and du okay. And now we know the integral of sin x dx, so we can as a function equal to x and then put the plus. Okay, simplify to there's a to use that formula by call one b what do dv all of that together and simplify. Definite integral, we could do that integration to find the indefinite integral and then evaluate the definite integral afterwards. Read with that method and how it works. Right, on the next page, there's an example. Find times t times e to the 2t. There. Separate. And e to the 2t. 5-10 in doing that. Right guys, what I'd be writing, assuming however far you got up to now, you've chosen 3t to be equal, u to be equal to 3t, and dv is equal to e to the 2t. Yep. Differentiating 3t ends up with du by dt being 3. Yeah. So du is equal to 3 dt. Yeah, is that right so far? And then the integral of this is, so we're finding u, that's iv, is equal to the result of that integration. Half e to the power 2t. Yep. So substituting in, we have the integral of 3t e to the 2t dt is equal to, and we want u 3t times v half e to the 2t minus the integral of half e to the 2t times 3 dt. Everybody get that far? Yeah? Yep. So that equals, where do we go next with that then? What can we do with this integral here to simplify it still further? So I'm going to write 3t half e to the 2t minus what can we do with constants? So it's all of that multiplied by 3. So yeah, you're right. That 3 could go in there. Okay, but then what can we, that's a constant times that function. What can we do with constants in terms of the integrals? Take them outside. So we can do 3 over 2 times the integral of e to the 2t dt. Everybody follow that? Yep. So that is equal to 3t half e to the 2t minus 3 over 2 times, what is the integral of e to the 2t? That's 1 over 2 e to the 2t, same thing before, and we've got a plus c on the end. And that's the answer. Multiply what back in? Yeah, you could do. You could multiply this one in as well, couldn't you? You could put that 3, get rid of the brackets there, 3t. So you could write 3t over 2 e to the 2t minus 3 over 4 e to the 2t plus c. Either of those answers give you the marks in an exam question. Okay? Right, on the next page, before we look at something that's a little bit more tricky, there's a definite integral for you to have a go at evaluating to get a final answer of a number at the end. Right guys, final answer, 2. After all that, well that's the answer. We let u equal 2 theta, dv equals sine theta, differentiate, integrate to find v that side, plug everything in the formula. We then have a simpler integral here, taking the constant outside that we can do from the table. Put all that together and end up with an indefinite integral. And here, with this, I would definitely separate out and find the indefinite integral and then put the limits on it and find the final answer. If I give you one of these, I may well even split that up within the question to find the definite integral first and give some marks for that, and then using it to find the final answer afterwards. Okay, so then we just plug that in with the limits and keep simplifying until we end up, when we plug the numbers in the calculator, end up with it equal to 2. Okay, so did anybody not get the answer 2 in the end? Did you not get that far, or? This next one, we'll have a go at doing that one together. All right, which we've got x squared. Right, guys, have a go at this one together. Which function are we going to try calling u? Let u equal. We'll let it equal x squared, because I know what and let dv equal sine x. Be patient, Michael. Alright, so what is the differential of x squared? (2x). So the u is equal to 2x times dx. V here is, so integrating sine x, it's cos x. We've seen that before somewhere. Yeah. Sure. So plug that into the formula for the integral, integrating by parts. X squared sine x dx is equal to, we want u, which is x squared, multiplied by v, which is minus cos x, minus the integral of v minus cos x times du, which is 2x dx. Okay. Now, can anyone see what the problem is there? Yes. If we simplify, if we write this out again as x minus x squared cos x there, minus the integral of, we can take the constant 2 outside of the integral, but we've got minus x cos x to integrate. We've still got an integral there to integrate, and in fact we could take the minus 1 outside as well, make that plus 2 the integral of x cos x. So we've still got on the right hand side, still got an integral we can't integrate from the table. So what we'd have to do here is apply the integration by parts to that integral again. We'd have to do it a second time. Because we still had x left, the reason is we've still got x involved when we've differentiated here. We haven't eliminated that version of the x variable because we had it twice in the original function up the top here, and we haven't eliminated it through the first differentiation. So we have to go through the integration by parts again to solve this inside here. We've already got an answer to that. That was the first problem we did. We've already done x cos x in the first problem that we had a go at. So we can borrow that answer and say that the answer to this is equal to minus x squared cos x plus 2 times whatever the answer to that first problem was. X sine x plus cos x all plus c. And that bit was from first problem for the notes. Yeah. So, in general, if there is a with a power n, i.e. x to the n, you would need to integrate by parts n times. The idea is that would take that to get rid of the x on the left-hand version of x. So if you had if up n times, if you would have to do it 10 times if that was x to the 10, like, yeah? No, I can categorically tell you that I won't give you x to the 10 in the exam. Okay? You'd need 10 answer books, I reckon. Alright, you'll get a mark, yes. Could be, could be. I haven't written the paper yet, Christian, so... Guys, are you ready to move on, please? What are we going to let u equal here? So, the differential of u equals x is 1, so du is equal to dx. Okay? What's v here? Integrate ln x. Is it in your table? No. You can integrate it. We're going to integrate it in a minute, but that's not in the table, is it? So, what do we need to do? Need to do this. Because we got a differential for ln x, haven't we? And let dv equal x. Du by dx is equal to, so if we differentiate, we get what? 1 over x. Du is equal to right, and we want v x squared over 2. Now we can plug into, say, that integral of x ln x dx is equal to u, which is ln x times v x squared over 2 minus the integral of x squared over 2 dx over x. Everybody follow that so far? Yeah? So we can write that as x squared over 2 ln x for that part. What can we do with this? We can take a constant half outside. Just because that's the better way round to write it, Dan, that's all. All it is x squared over 2 multiplied by ln x, so it don't matter what order you put them in. That's more natural to have the log function after. Right? I've taken the half outside, x squared. If I do that, yeah, that's right. What can I do now? What can I do in here? I've got x squared times dx over x. That can go, and that can go. Yeah? So it equals x squared over 2 ln x minus a half. And what's the integral of x? Already got it, haven't we? Done that once already. No, we haven't. Integral of x. We did do it somewhere because we got x squared over 2. Yeah, we done it when we had it the other way round, didn't we? When we said let u equal x. Is it not x squared over 2? Yeah. Let's see. Yeah. Anything else we can do to simplify that? Not saying you would have to as an answer in an exam question. I'd take that. But we could multiply out this half and this half in here, couldn't we? Make that x squared over 4. Could do. Yeah. Aye or nay? See that or not? Okay. So, can anyone think of a way? Yeah. Go on. Haven't done that. Can anyone see how we could integrate ln x? We got nothing in the table. It's not in the standard table, and in standard integral of a natural log of x. Pretend there's a 1 in front of it. Yep. So we could write that as one times ln x dx. Then what would we do? Off we go then. Let u